Let's now see how we can create file and write to that file immediately. For this example, first we will write new function check. To this function, we will pass each variable of data type error, and if there is any error inside of that specific variable, we will print that error as our new log. Let's now see how we can write to our specific file. First, we will create a new variable d1, which will be value of data type string converted, which means casted into our slice of bytes. Then we will call our write file function from our eoutil package, and we will specify three values. First value will be location and specific name for our new file. Second will be data, which we will want to write inside of our new file, and third value will be permissions, which we want to give to our new file. Our write file function will delete all content inside of our file and replace it with value of our d1 variable. After that, with function check, we can check if there is any error inside of our execution. Also, we can do this in different way with buffer. We will create new file with create function from our OS package. Then we will check if there is any errors, and after that we want to close our buffer, which is in this case our f variable. But now in front of that function we specified defer reserved word, because we don't want to close our buffer immediately. We want to close buffer at the end of our main function. That's why we use defer. Now let's create new slice of bytes. We created a new variable d2. This variable will have data type of slice of bytes, and we specified 5 new values. This slice of bytes will present string sum. Each specific value of byte will be transformed into one specific character. How we can know which transformation will happen? You can go on this location, and inside of our huge table you can see which value of byte will be transformed into one specific character. After all this, we will take our f variable, which is our buffer, and we will call our write function. We will pass value of our d2 variable to our write function. Then we will check if there is any errors inside of execution of our function, and after that we will print value of our n2 variable. This value will tell us how many bytes we wrote inside of our file. Instead of writing specific slice of bytes, we can use also write string function for our buffer. We can pass specific value of string data type to that function instead of writing slice of bytes. After that, we will check if there is any errors, and for last, we will print how many bytes we wrote inside of our file. So at this point, we must understand one important thing. All data which we wrote, technically we didn't wrote inside of our file. We wrote that data inside of our buffer. This means that our buffer keep our data inside of our RAM memory, which means that this data isn't written on our disk. So now the question is how we can write our data from our RAM memory to our disk. To do that, we will access our buffer and we will call function sync. This function will synchronize data from our RAM memory to our disk. And then after that, we can see our new data inside of our file, while our buffer, which keep our data, will be empty. Our buffer is empty because we removed our data from our RAM memory, so we can transfer that data to our disk. Let's now execute our application. we can see that we have executed two different writings inside of our file. Let's now see the content of our file. In first file, text1, we have hello Golang in two different lines. Next, in our text2 file, we have some writes also in two different lines. So we executed our writings successfully. Let's now see how our buffer can help us with writing of our files. We will call our openFile function from our OS package. After that, we will check if there is any errors, and we will call close function for our buffer with defer. We want to use our file variable as our new buffer. With that buffer, we will create new writer with function new writer from our Buffio package. In this case, we created a new variable, buffered writer, and that will be our writer. Now we can call that variable, so we can call write function. Now we can pass slice of bytes into our write function. After that, we will check if there is any errors, and we can print value of our bytes written variable, so we can see how many bytes we wrote inside of our file. Our buffered writer variable can call write string function. In this case, we didn't pass slice of bytes to our buffered writer variable, and instead of that, we passed specific value with data type string. So, what is the purpose of this kind of writer? This kind of writer can be extremely beneficial to us because he can provide for us additional informations. We created a new variable, unflashed buffer size, by calling buffered function from our writer. This value will tell us how many memory we keep inside of our buffer. In first case, we kept 3, and in second case, we kept 16 bytes, which means that our buffer at this point has 19 bytes inside of our memory. Also, we can check how many memory is still available for our buffer. We can do that by calling function available from our writer. When we print value of our bytes available variable, we can see that we have left 4077 bytes. After that, we can call flush function from our writer, so we can write our data from our memory to our disk. Also, we have reset function for our writer, which means that if we don't need to write our data from our RAM to our disk, we can reset and delete all data inside of our buffer so we can write new data. In this case, when we execute our reset function, we won't change anything because we already flushed our data to our disk, and our writer, which is our buffer, is already empty. So at this point, we will reset already empty buffer. When we again check how many available bytes we have inside of our buffer, we can see the difference between empty buffer and buffer which contains some data. Now we can see that our available bytes for our buffer is now value of 4096 bytes. This value is equal to value of 4 megabytes. This is default value for our buffers, but if we need a larger number than 4 megabytes, we can resize our buffer. We can assign new value to our buffered writer by passing that specific variable to our new writer size function from our Buffio package, and for second input variable we will specify new value which we want to use as size of our buffer. If in any case we specify value which is smaller than 4 megabytes, our buffer will keep value of 4 megabytes, because that is minimum value which our buffer must contain. When we again check size of our buffer with function available, we can see that now size is 8000. Now we can execute our file and go to open our test2 file so we can see our modifications. We can see the output of our application. Let's see our test2 file. We can see that we have new value inside of our file. Let's now see how we can copy data from one file to another. For this case, first we will open specific file and then we will create a new file so we can copy data from first to second file. So for start, we will open our test2 file. Our original file variable is our new buffer. We will create a new file with our create function, and we will get also new buffer as new file variable. After this, we will use our copy function from our EO package so we can copy data from one buffer to another. Our bytes written variable contains value of how many bytes we copied from one buffer to another. We can see that this value is 19 bytes. Now we didn't yet copied that data to our new file. For that, we must call our new file buffer and call sync function so we can write this data from our RAM to our disk. We can execute our application and see new data inside of our new file. We can see the message of our application, and now we can open our test3 file so we can see the last modifications.